Hey, 3-year-old Ben, are you here to wish people good luck with their National 5 maths?
Good luck for your National 5 maths.
It's time for Maths with Mr. Thomas.
That's right, it's almost exam time, so let's look at some past paper questions based on what we have done in this trigonometry and bearings chapter. Are you ready? Yes, I am! Then let's do it. Let's jump all the way back to 2019 and let's look at this paper 2 question. Paper 2, does that mean it's calculator? It does indeed. So, the diagram here shows triangle PQR. PQR. PR is 45 centimetres. PQ is 70 centimetres. And angle QPR is 129 degrees. Calculate the area of the triangle. So, what are people thinking for this? How do you get the area of this triangle? Oh, look at the formula sheet! We do look at the formula sheet, and what are you thinking? Sine rule or cosine rule?
No, don't be silly. It's nothing to do with sine rule or cosine rule. It's to do with the area.
It is indeed, yes. Yeah, if you pay attention to what Jane has said, the area of the triangle is what you're asked for. So when you look at the formula sheet, what you're looking for is this. Bam, bam, bam! And it says the area equals a half AB sine C. What you know by now, we did this in the area of a triangle chapter, is that the sine C part, the C is the angle, and the A and the B are the two sides either side of that. So here, the C is going to be 129 degrees, and the A and the B are the 45 centimetres and the 70 centimetres, which means we can write out area is a half AB sine C, which is equal to a half times by one of the sides, times by the other side, doesn't matter the order in which you put the sides, times by sine C, and C is 129 degrees, so it's times by sine 129 degrees. And if you put that into your calculator, beep, 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 you get 1,224.0 squared centimetres. Woo! And that's the area of that triangle.
Oh, you made that look so easy.
It is. Do you want to try another one?
Yes, please.
Okay, let's jump to 2015 and look at this paper 2 question. Again, paper 2 means it is a calculator question. So, the top of a table is in the shape of a regular hexagon. So all the angles and all the sides are the same. The 3 diagonals, which are shown as dotted lines, each have a length of 40 centimetres. So this length is 40, this length is 40, and this length is 40. Calculate the area of the table.
Problem solving question. We don't know how to get the area of a hexagon.
Correct, yes. So what do you think you have to do, Christopher? Because you can't just work out the area of the hexagon straight away. Does anybody have any ideas? Oh, Marie, what do you think?
You can work out the area of a triangle.
Yeah, perfect. You could work out the area of just one of these triangles. And if you had the area of one of them, well, if we worked out the area of this, what could you then do?
Times it by 6, because there's 6 of those triangles.
Perfect. Yes, that is exactly what you would do. So if you take just one of those triangles, what would the length of the sides be in the triangle? How far is it from here to here?
Oh, it'd just be 20, because the whole dotted line is 40. So that bit's 20.
And the other bit
is 20. Woo!
And the size of the angle. How would you work out the size of the angle? Chloe, what do you think you would do?
Would you do 360 divided by 1, 2, 3, 4, 5, 6?
You do indeed, yes. You do 360 degrees divided by 6 means that one of these angles is just 60 degrees. So, to work out the area of this triangle, once again, what are you thinking?
It's a formula!
It is indeed, yeah. The area of a triangle is a half AB sine C. So, sine C, the C is going to be the angle, and A and B are the two sides either side of the angle. So, the area of one of these triangles is a half AB sine C, and if you put your numbers in, that's a half times 20 times 20 times sine over angle, so times sine 60. If you put that into your calculator, beep, 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 you get 173.205 and so on squared centimetres. But remember, that's not your final answer, so keep that answer on your calculator. And then what do you do?
Well, you've worked out the area of one triangle, and there's 6 of them in total that make the hexagon. So take the area of one triangle and times it by 6.
Yeah, well done. You're right, Jack. That is exactly what you do. And if you do that, you end up with an answer of 1039.23 square centimetres to a couple of decimal places. I would always round your answer to either 1 or 2 decimal places. That is what you get. Woo! Here we go for another one. Example 3 from the 2017 paper. Paper 2. So once again, paper 2. So it's a calculator problem. A piece of land is in the shape of a triangle. The owner wishes to build a fence along the side QR to stop the cows getting out. So there's QR. Calculate the length of this fencing. Anybody have any ideas?
Well, this time, Mr. Thomas, it was not to do with the area, so we're not using the area formula.
You're right, Marley, we're not doing that. So what would you do?
You would think about the sine rule or the cosine rule.
Yeah, you would. So if you think about the cosine rule or the sine rule, which one would you use?
Well, I always think about the cosine rule first of all.
So do I. So if you think about the cosine rule first of all, use the cosine rule if you know all 3 sides. Do you know all 3 sides? No! Or if you know 2 sides and the angle between them. So here we know 2 sides and the angle between them, so we can use the cosine rule. Cosine rule is written 2 different ways. You've got cos A equals, and that's when you want to work out the size of an angle. If you want to work out the length of a side, it is this one here. A squared equals B squared plus C squared minus 2BC cos A. Once again, in this formula, the lowercase letters represent the sides and the capital letter represent the angle. So, because this 147 is the only angle we have, our A has to be 147. Meaning if this here was angle A, across from that would be our small a, which means the B and the C are the other 2 sides. So we've got our B and we've got our C in any order you like. We are wanting to work out the side QR, so you could either call that A, as long as you finish off by saying QR is this, or the length of the fence is this. But what I'm doing is just putting in QR, because that is the length of that side, QR. So QR squared equals B squared plus C squared as the other 2 sides, so 250 squared plus the 180 squared. Take away 2 times by the 250 times by the 180 times by cos of our angle, cos of the 147. If you put that into your calculator, beep, 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 you end up with 170,380.3511. But the length of that fence isn't going to be 170,000. That's crazy! What else do you have to do? Good! What we've worked out is QR squared. We don't want QR squared, you want QR. So how do you go from QR squared just to QR?
You undo the squared.
And how do you undo squared?
Take the square root.
Perfect, yes, take the square root, really, of both sides. So QR would be the square root of the 170,000 and so on. And if you work that out, you end up getting the 412.77 metres to a couple of decimal places. So that is the length of fencing required. Woo! Here's another one from the 2023 paper 1.
Ooh, it's a paper 1! That's not a calculator!
It is indeed, yes.
I'll put my calculator on the floor. Here we go, I'm ready.
Okay, so now you're ready with this. What do we do, Sam?
Don't know, can someone else help?
Okay, so in triangle ABC, AC is 5 metres, BC is 6 metres, and cos C, so cos of this angle is 1/5. Calculate the length of AB. So once again, we know it's not the area, so we're not using the area formula, so we know it's going to be sine rule or cosine rule. I would always start you thinking about the cosine rule. So use the cosine rule if you know all 3 sides, or if you know 2 sides and the angle between them. So we don't know all 3 sides, but we kind of know the angle between them because we know the cos of the angle, and that still counts. So we know two sides and we know the cos of this angle between them, so we can still use the cosine formula. And the cosine formula for the sides is this. So we've got a squared equals b squared plus c squared minus 2bc cos a. Start with what you're wanting to find. So we're wanting the length of AB. I would ignore the letters that they give you. They're just going to try and confuse you when they bring it up. You know, in this formula, the A is the only angle, and the only angle we are told the cos of this angle. So that really there is going to be A, although they are calling it C. Meaning if that there is the A in our formula, across from that, that side has to be small a. So the B and the C, doesn't matter which way around you have it, one of them is B and one of them is C, but this one here, the missing one, has to be A. So we're going to start with that. You could always write a squared equals, or you could use the C that they give you, as long as you know that it's going to be this squared equals these two sides squared and added, take away 2 times these two sides times cos of our angle. So going with that, this side they are calling AB in the question, so I'm just sticking with that. I'm just sticking with AB. So AB squared will equal, you've got the other two sides, either side of our angle. So b squared plus c squared becomes 5 squared plus 6 squared. Take away 2 times both sides, so take away 2 times by 5 times by 6 times by, and then it's cos of our angle. What it's telling us in the question is it's telling us the cos of the angle. Do not write down cos 1/5. It's telling us the cos of the angle is 1/5, which means we can replace the cos and the angle with just 1/5. So we can get that. From there are multiple ways to work that out. One thing that jumps out is you've got the 5 and then the times by a 5th. The 2 times 5 times 6 times a 5th you can do in any order you like. If you do 5 times a 5th, well, it's just a 5th of 5. So really, if you cross them out, they just become 1. So you've got 2 times 6 times 1. You do it different ways, but really you would end up with the 5 squared is 25, 6 squared is 36, and 2 times 6 times by 1 if you want, or just 2 times 6, gives you 12. Or you could do 2 times 5 times 6, 60, and then take a 5th of that. It's 12. It still works out as long as you can do that without a calculator. 25 and 36 take away 12 gives you 49! Good. Again, you know that length's not going to be 49. If that's 5 and that's 6, 49 makes no sense. It's way too high. Square root it! Good, well done. You do have to square root it. So, it means AB is the square root of 49, and without a calculator, that is dead easy. Oh, well done. Here's another one from the 2014 paper 1.
Oh, paper 1 again, that's another non-calculator.
It does indeed, yeah. And this time we're asked to work out the length of going from L to M. That is what we're wanting to find. We are told that KM is 18 centimeters. We know sine K, so we know the sine of this angle, and we know sine L, so we know the sine of this angle here. So, in order to solve that, in order to work out this side, LM, that's what you're wanting to find, how do we go about doing it?
Think about the cosine rule. Use the cosine rule if you know all 3 sides.
Do you know all 3 sides in this one?
No. Do you know 2 sides and the angle between them? Because that's when you would also use the cosine rule.
No, you don't. You don't know 2 sides and angle between them.
Then it has to be the sine rule.
Perfect, yeah. Use cosine if you know all 3 sides, or 2 sides and angle between them. And if you don't, then it's the sine rule. And for the sine rule, what do you look for? Pairs! You always want to look for your pairs. So, Lewis, what are the pairs here? Well, you're wanting to work out LM, and that's paired up with the angle across from that, which is K. But really, we're given sine K. So sine K and K, well, that kind of goes there. So we've got that and we've got that. So that's a pair. Good, well done. What else, Rejwan?
Sine L. Sine L you're given, and sine L is really that angle, and that's paired up with the 18. So you've got the 18 and you've got sine L, so that's another pair.
Good, yeah, perfect. And whenever you use the sine rule, just start with what you want to find. Because it is the length of a side you're wanting, the side is going to go on top. So it sticks with A over sine A, B over sine B, C over sine C. If it was an angle you're wanting, you just flip the sine rule upside down. For sine A over A, sine B over B, sine C over C. But just leave it as is because it's the side you want. So this side is LM, so I'm just going to stick with that, calling it LM, and that would be divided by the sine of whatever that's paired up with, and it's paired up with K. So it's going to be sine of K. That is equal to, the other pair we have is the 18 and the sine L, so it's going to be the 18 divided by sine L. With these though, sine K and sine L, we know what they are. It tells us up here just in the purple writing. So sine L is 0.4. So really we end up with LM over 0.4 equals the 18 divided by sine L, and sine L is 0.9. So LM over 0.4 equals 18 over 0.9. To get LM just on its own, you have to get rid of divide by 0.4. How do you get rid of divide by 0.4?
Times by 0.4.
Good, so you multiply both sides by 0.4. So LM will equal, and you're going to have the 18 times 0.4. If you multiply by it just goes on the top, and you divide by 0.9. Again, notice the 18 is on the top, 0.9 is on the bottom. They are not changing. You just put in the times by 0.4 on the top. You have to work that out without a calculator.
How do you do that without a calculator?
Well, one of the ways of doing it is to get rid of the decimal. Because we've got a fraction here, what you can do is if you multiply the top and the bottom of a fraction by the same thing, it doesn't change the fraction. For example, if you've got the fraction a half, if you multiply the top by 5, you get 5. If you also multiply the bottom by 5, you get 10. 5 out of 10 is still a half. You have not changed the fraction if you multiply the top and the bottom by the same thing. So to get rid of the decimal, to go from 0.4 to a whole number, one way to do it is to multiply that by 10. But if you multiply the top by 10, you'd also have to times the bottom by 10 as well. So I'm going to do that. So it's 18 times 0.4 times 10, and then times 1 by 10 on the bottom. And the reason I'm choosing times by 10 is if you do 0.4 times 10, you end up with a whole number. And whole numbers are dead easy to work with. Same at the bottom, if you do 0.9 times 10, you get a whole number. So LM is going to equal, that becomes 18 times by, what's 0.4 times 10? 4! Good. And 0.9 times 10? 9! Brilliant. So you get 18 times 4, and then divide by 9. You can do that different ways. If you do 18 times 4 and then divide it by 9, or I would do 18 divided by 9 first of all. What's 18 divided by 9? Well, if you do 18 divided by 9, they both divide by 9, so that's going to give you 2 there, that's going to give you 1 there, or it's just going to leave you with 2 times 4. You could think about that. So you get 2 times 4, which is equal to 8 centimeters for your length. So LM is 8 centimeters. Woo! And I've just started to go sideways here. I'd probably do it below it if I were you in an exam. I'm just trying to put it on the page. Hopefully that makes sense. Example 6 from the 2023 paper. Paper 2. Here is triangle JKL. Angle KJL. KJL is 25 degrees. JL, going from J to L, is 10 meters. And KL, from K to L, is 7 meters. Calculate the size of angle JKL. JKL. So, from J to K to L, that is the angle you are wanting to find.
So once again, you think about the cosine rule.
You do? Yes. Go for it, Rich. So you use the cosine rule when
you've got all 3 sides.
Do you have all 3 sides?
No.
Or you use it if
you've got 2 sides and the angle between them.
Do you have 2 sides and angle between them?
Well, I've got 2 sides.
Do you have the angle between them? Do you know this angle, or the sine of that angle, or the cos of that angle? Do you know anything about the angle?
No.
Then you can't use the cosine rule.
Which means it's sine rule!
Brilliant. So, because here we're wanting to work out the size of an angle, what we're going to do is we're going to take the formula that's on the formula sheet and flip it upside down. So instead of A over sine A, we've got sine A over A. We'll put the angles on top. Again, in the formula, the capital letters represent the angles. And because you want to find an angle, we put that on top. It's just the formula in the formula sheet upside down. We are wanting to work out this angle here, K, and we have to look for our pairs whenever we're dealing with the sine rule. So angle K is paired up with the 10 meters. So we are going to have, we're starting with K, so we're going to have sine K. So sine K over, and that's paired up with the 10, is going to be equal to, what would that be equal to? What's our other pair?
25 degrees and 7 meters. We know both of them.
Good. A pair is when you've got an angle and the side across from it. So it is going to be the sine of the angle, sine 25, divided by 7. Yeah. We want to get sine k just on its own, so how do you get rid of the divide by 10?
Do the opposite.
And the opposite is times by 10. Good. So sine 25 and 7 just stay where they are. But what you also do is you multiply by 10. Rather than doing sine 25 times 10, just watch some of the calculators might then do 25 times 10 and give you sine of 250, which is wrong. It's 10 times by whatever sine 25 is. So I just write that first. If you work that out on the calculator, it means then that sine k is 0.6037 and so on. We don't want sine k though, we just want to get k. So how do you get k on its own? What would you do?
You do sine to the minus 1.
You do, yeah. So sine to the minus 1 of, and again, keep that answer super accurate on your calculator. So sine to the minus 1 of the 0.6037 blah 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 gives you an answer of 37.14 degrees to a couple of decimal places. Remember, give your final answer to 1 or 2 decimal places unless you are asked otherwise. Example 7 from the 2019 paper 2. So it's a calculator problem. Calculate the size of the smallest angle in this triangle.
Which one's the smallest one?
Well, the smallest angle...
Oh, I know this one. The smallest angle is always across from the smallest side.
It is indeed, yeah. There is the smallest side, the 6.3 centimetres, and the smallest angle, you can maybe tell by looking at it, that there is the smallest angle. So one thing to know is the largest angle is always across from the largest side, and the smallest angle is always across from the smallest side. Woo! So, with this one here, you want to find that angle. So, what do you do?
Well, we know it's not right angled, so we're either going to be using the sine rule or the cosine rule.
Good. So think about the cosine rule first of all. Use the cosine rule if you know all 3 sides or 2 sides and the angle between them.
How will you know all 3 sides? So it's just straight into the cosine rule.
Good. The cosine rule, it's written 2 ways in the formula sheet. It's a squared equals b squared plus c squared minus 2bc cos a.
But that's if you want to find out a side. If you want an angle, it's cos a equals.
Good, so that is the formula you are looking for. Once again, the letters that they give you, you can just ignore them completely. And think here, the capital letters represent the angles, and because we're wanting this angle, it means this angle is really going to be our A. So across from that angle, that would be our small a in our formula. So that there, the 6.3 is going to be our A. And the B and the C then would be the 7.2 and the 8.5. And it doesn't matter which way around we have them with the B and the C, as long as the A is the 6.3. So we're going to have then cos, what they were calling it Z in the questions. So I'm just going to stick with cos Z equals B squared plus C squared. That's the 8.5 and the 7.2. And we're taking away that 6.3 squared. Divided that by 2 times by the 7.2 and the 8.5. Again, doesn't matter the order of them as long as the 6.3 is here. That's the one we're taking away. If you work that out on your calculator, you end up with 84.4 divided by 122.4. And if you keep going with that, you could work that out as a decimal if you like. But that's what cos Z is going to be. That's the cos of this angle.
We don't want cos Z, we want Z.
We do, we want Z. So how do you get Z just on its own?
Get rid of cos.
And how do you get rid of cos?
Cos to the minus 1.
Good, so cos to the minus 1 of the 0.6895 and so on. Keep the answer super accurate on your calculator. Do shift cos equals, inverse cos equals, second cos equals. Get cos to the minus 1 of that previous answer. And you end up with, to a couple of decimal places, 46.41 degrees. You could also write it as 46.4 degrees. Again, go to 1 or 2 decimal places. But that is your answer. Yarr! Example 8.
Oh, it's a bearings question! I hate bearings!
Lots of people say that, but don't freak out. Read the question, take your time, think about it. It's just going to be a triangle problem. So, with this one from the 2018 paper, paper 2, a ferry and a trawler receive a request to help a stranded yacht. The ferry is on a bearing of 240 degrees from the trawler. Calculate the bearing of the yacht from the trawler. What on earth is this on about? What are we wanting to find? Well, don't freak out whenever you get this type of question, Hallie. What you've got to do is you've got to think. We are wanting calculate the bearing of the yacht from the trawler. So these words should be jumping out. It says from the trawler. When I was talking through this lesson, I kept mentioning us getting a Christmas card from Care. And because it was from Care, the Christmas card would be starting with Care. And because it's starting with Care, that's where you start, wherever it's from. So because it is from the trawler, we are starting at the trawler. F is the ferry, Y is the yacht, and T is the trawler. So that is where we are starting. And we're wanting the bearing from this point to the yacht. So what that means is we want the size of the angle from north right the way around up to this line that points out towards the yacht. So we want to work out the size of this angle right here. How can we go about doing that though? Does anybody have any ideas?
Yes! You already know that from north right the way around to that line that points towards the ferry, and I don't know why it's got a capital F there.
Yeah, me neither.
We already know that's 240 degrees. So all you want to find is just what that angle in the triangle is. All you need to do is find that.
You're right, yeah, well done, Nella. So if you work out that angle, you can just add it on to the 240 degrees. So let's do that. Let's work out the size of this angle in the triangle. How do we do that then? Can anybody help us?
Yes, use the cosine rule if you know all three sides. Or if you know two sides and the angle between them. Here, because we know all three sides, we can use the cosine rule.
Yeah, you're perfectly right. Well done. So, using the cosine rule, because it's an angle we want, it's the formula which is cos A equals. This is the angle we are wanting to find, meaning this angle here really is going to be our A. And if this angle here is A, then across from that is going to be our small a. Meaning the B and C will be the 5.6 and the 10.3. Again, doesn't matter which one is which, as long as the 7.2 is the A. So because we're wanting to work out that angle there in the triangle at T, I'd probably be writing cos T equals B squared plus C squared is going to be the 10.3 and the 5.6. Again, doesn't matter the order, and you're taking away A squared, so you're taking away 7.2 squared. Divide that by 2 times by the B and the C, so 2 times by 5.6 times 10.3. And if you work that out on your calculator, you get 85.61 divided by 115.36, and if you take that further to get it as a decimal, you get 0.4. No, you don't. You get 0.7421 and so on. Keep that answer super accurate, and then just get T on its own. And how do you get T on its own?
Oh, you have to do cos to the minus 1.
Good, so cos to the minus 1 of that 0.7421 gives you an answer of 42.09 degrees. So to answer the question, the bearing of the yacht from the trawler, that is going to be the angle from here right the way around to here. So we know from here around to this bit is 240 degrees. We are told that, and all we have to do is add on the 42.09.
But you can just write it as 42 because it's bearings, and bearings are 3-figure bearings, which is just whole numbers.
Good, yeah, so we don't really need the 0.09, so we're just adding on the 42. Means then the bearing is going to be 282 degrees. Woo! That will be your answer.
Oh, that wasn't as difficult as I thought it was going to be. I'm slightly embarrassed now.
That's alright. Let's try another one. One more. Final example. Example 9 from the 2018 paper. Another one from the 2018 paper. Calculate the length of DC. Going from D to C. How do we do that? Well, once again, if you look at this, you've got this triangle. And when we've got a triangle, we're thinking about either the area or the sine rule or the cosine rule. We know here it's nothing to do with area because we're not told the area, we're not asked to find the area, so it's nothing to do with the area equals a half AB sine C. So we know it's going to be the sine rule or the cosine rule. But the first thing you could do before you start to think about what you want to find, start to fill out any angles. Are there any angles that anybody thinks they could fill out? Well done, good, this angle just at the top. you know that this line here, ABC, is straight, which means then that it's grading to 180 degrees. So if you take away the 75, it means that this angle here is going to be 105 degrees. So we could fill out that first of all. So we've got the 105 degrees. From there, you could always work out that angle at the bottom, because if you add these two angles together, you could take them away from 180, and then you could work out this angle as well. So we've got that. But here we don't actually need it. We're just wanting to work out this length from D to C. That's what you want to find. So once again, think about, well, is it going to be the cosine rule or the sine rule? Use cosine if you know all three sides. Do you know the length of all three sides of the triangle? No, you don't. Or use it if you know two sides and the angle between them. Do you know two sides and the angle between them? Once again, no, you don't. So what do we have to use? Sine rule! Good. So once again, you're using the sine rule. Is it going to be the sine rule for the side or the angle?
It's the side, so we put the side on top. A over sine A, B over sine B, C over sine C.
Good, well done. If it was an angle we're wanting, we just use the sine rule, but flip it upside down. Sine A over A equals sine B over B equals sine C over C. We are wanting to work out the length of this side, and that is paired up with this angle here at the 105 degrees. So we're wanting to use that. So we're starting with what we want to find, and we've got the side DC divided by sine of the angle it's paired up with. And the angle across from the side DC is 105. That's going to be equal to, and we need to get another pair. What's another pair? Well, we know that 20 centimetres, and we know the angle across from it. We know that is 37. So we can say, when we use the formula, the ABC represent the side, the lowercase letters are the sides, and the side here is 20. So it's 20 divided by sine over angle, and the angle is 37. If you get DC just on its own, you're getting rid of divide by sine 105. So you multiply both sides by sine 105. So it's a 20 times by sine 105 divided by sine 37. Again, when you multiply, you put whatever it is you want on the top. And from there, how would you work that out?
That's paper too, so just use your calculator. Here you go, use mine.
And you end up with 32.1 centimetres. So that is the length of DC that we are asked to find. Woo! There you go. Hopefully that has helped. Going over some of the past paper style questions. These are the sort of things that they asked in the trig and bearings chapter in the exam. If you want some extra practice, try the other past paper questions. There are a few more. There's also been more since this video was made. Or you can try some of the questions in the Zeta book or the National 5 Maths TJ book. There's plenty of books out there to practice trigonometry and bearings. Best of luck. Good luck with the exam. Woo! See ya.